How is a Moorish sundial made? The first crude sundials or shadow clocks consisted merely of upright poles or obelisks mounted on a stone base. By measuring the angle of the sun's shadow with respect to fixed graduation, usually at 15 degrees separation, it was possible to get a rough idea of the time of day. The trouble with such shadow clocks was their inaccuracy when compared with the fixed interval of the hourglass or water clock. The Moors, who made great headway in the study of spherical trigonometry, discovered that this behavior was a result of the changing angle of the sun as the earth progressed through its seasons. The angle between the sun's shadow and the north-south meridian is defined as the sun's azimuth, but the azimuth angle, the angle through which the sun's shadow rotates when the sun has moved through the given angle, changes with the seasons. The Moors saw that this condition should be eliminated merely by aiming the shadow pole at the North Star, Polaris, instead of straight up in the sky. In other words, the axis of the shadow pole shall be parallel to the axis about which the sun appears. So to the Moor that made the comment speaking about the Moors don't have anything to do with the Big Dipper or the North, it says right here, Moors saw that this condition could be eliminated merely by aiming the shadow pole at the North Star, Polaris, instead of straight up in the sky. In other words, the axis of the shadow pole should lie parallel to the axis about which the sun appears to rotate through the sky. The proof of this discovery is beyond the scope of this book, but that will not prevent us from using the information as the Moors did to build an accurate sundial. First of all, the style should be set so that it lies in a north-south direction. Then the top edge should be tilted above the horizontal at an angle equal to the latitude of the location for which it is made. The top edge of the sundial will then point at the North Star, since latitude is nothing more than an angle of the North Star above the horizon. When this has been done, the top edge will correspond to the Earth's polar axis, and the scale can be graduated into divisions which will measure equal intervals of time at all seasons of the year. The next step is constructing our sundial is to determine the angles for each of our hourly divisions on the scale. This can be done by using the following formula. Tangent, shadow angle equals sin, latitude times tangent, hour angle. Here's how this formula is used. Let's suppose that we want to make a sundial for use in New York City, which has a latitude of 41 degrees. We must first cut a style so that its upper edge makes an angle of 41 degrees with the base. Then the base must be mounted so that the upper edge of the style points due north. The only remaining step is the use of our formula in determining an angle for each of the scale divisions. Since New York is a latitude of 41 degrees, we must look up the sine of 41 degrees, usually written sin 41 degrees, in a table of sines for use in the formula. According to such a table, sin 41 degrees equals 0.6561. This number will be used for the sine, latitude, for the equation. Since the noon shadow will point directly north, we can use 12 noon as a convenient point of reference. After 1 p.m., the sun will have turned through exactly 15 degrees, which is 1/24th of a complete revolution of the Earth. Also at 1 p.m. exactly 1 hour will have elapsed since noon. The angle in degrees is then 1 times 15 equals 15 degrees. Looking this angle up in a table of natural tangents, we find that tan 15 degrees equals 0.2679. The tangent of the shadow angle is then tan. Shadow angle equals sin 41 degrees times tan 15 degrees equals 0.6561. times 0.2679 equals 0.1758. Looking up 0.1758 in the table of tangents, we find that it falls between the angles of 9.9 degrees and 10 degrees, for which the tangents are 0.1745 and 0.1763 respectively. So we can take 10 degrees as the shadow angle for 1 p.m., correct to 1/10 of a degree. In calibrating the sundial, we would work off an angle of 10 degrees east of north for the mark of corresponding to 1 p.m. Similarly, the angle corresponding to 2 p.m. would be determined by setting the hour angle equal to 2 times 15 degrees equals 30 degrees. Looking up tan 30 degrees in the tangent tables and substituting that number in the equation. In this way, all the hourly shadows angles can be computed and marked off on the scale. After having completed your sundial, if you can induce it to ring at some predetermined time in the morning, you will have accomplished the first major improvement to the sundial in the past 1,000 years. Needless to say, Those of us that are subject to the uncertainties of rural electrical systems would be certainly grateful. Who first measured the size of the earth?